The Great Search brought to you by DigiKey and Adafruit. Every single week, Lady Ada uses her power of engineering to help you. Yes, you find things on digikey.com. Lady Ada, what are you looking for this week?
Okay, this week we actually had a request, and I thought this would be, and I was like, this is a really good request, and also I will put it on the Great Search, and I gave them some advice. So we have in the shop we have these PT1000, PT100 RTD sensors. These are ultra stable, precise temperature sensors that can measure like a remote sensing, and they have like a wide temperature range. They're a little expensive because they use true platinum, but like they're extremely stable and reliable. So these are used for like people when they really need like good temperature readings that are consistent, have a wide range. You can do 3 or 4 wires, so you have the resistance of the wires taken into account. It's all really good stuff. And we tend to use the Max 31865, which is an SPI sensor that does a lot of the work for you. And look, I do recommend this sensor. It's in stock at DigiKey, originally Maxim, now Analog Devices. It's a great RTD amplifier that does all the work for you. Like it's like once you follow the data sheet, you will get the actual temperature out. And you just have to have the matching, you tell what the matching resistor is with the resistance of the platinum piece. The person was asking, well, this is SPI and I really want I2C. And what's interesting is that there is for thermocouples, there is the MCP 96001 series. And these are I2C. They're not inexpensive, but they are I2C thermocouple readers. So they can do, I think, like K and J type thermocouples. Thermocouples are not as precise or accurate as RTDs. And so this person said, look, I want to do RTD stuff, but I want it to be over I2C. And I quickly looked and there is no I2C like specific RTD sensor. But the good news about RTDs is they're very linear because they are like this piece of platinum, and as it heats and cools, the resistance like changes a little bit because it's a very thin piece of platinum. You just need if you have 0.1 resistor dividers or the Wheatstone bridge, you can use an analog digital converter. And so what I thought we would look for today on the Great Search is a 24-bit I2C analog digital converter chip. And then you would be able to use some resistors and basically do the RTD reading. And you'd have to do the math, but the math isn't too bad, to be honest. So let's look for ADCs. And there's a lot. There's 14,000 ADCs, not surprising. So let's look at only active ones. And so that gets rid of all the ones that have been discontinued. And number of bits, as I mentioned, we really want a 24 or greater bits because to get the real, if you look at like any of the RTD sensors, they really use 24-bit ADCs. Now, the good news is it doesn't have to be very fast, but it is, you do need 24 bits, and you want it to be pretty good quality. Okay, next step, we should filter it out so it's only I2C. So let's search for data interface and search for I2C and select that. Okay, now I only have like 25 options. And then let's get rid of marketplace just because that doesn't even matter. And then we'll look at also normally stocked because some of these are like, not really stocked or made anymore, like they're rare. Okay, so then let's sort by price real fast, just because we care. Oh, sorry, and surface mount. I think there's like one that's through hole. I don't know how they got a 24-bit ADC in through hole, but I don't know. Somebody wants it. So starting off, so some of these are duplicates because they're just these are different package types like tube versus tape and reel or cut tape. That's okay. So there's the NAU 7802, and we have a breakout for this chip. We use it for strain gauges, and it is a 24-bit ADC, and it's really kind of designed for strain gauges. I wouldn't call it a super. It does have precision, but I wouldn't call it accurate. It's a very the price reflects like what you're going to get. It does work, but I would use it for stuff like strain gauges where you calibrate it. And it's okay if there's a little bit of drift. Whereas for RTDs, I think we should get maybe a higher grade of sensor. So there's the LTC 24.8 5. And linear tech, analog devices, you're going to get an amazing ADC. This one does do differential, which we probably want, because if we're doing this Wheatstone bridge, having differential measurements is you're going to get better results, or not more accurate, but you're not going to deal with common mode as much. You'll, as long as you stay in the middle there, you can get pretty good accuracy and precision. But the sampling rate's quite low. It's only 7.5 samples per second, which is not unreasonable. And also there's only one input, which I think is okay. And it costs about like $4 in quantity. And then there's the 2493. This one is twice as fast. So you're going to get 4 single-ended or 2 differential inputs at 15. And this is like 75 cents more. So this is kind of like the slightly fancier version of the 2485. And then we've also got the ADS 1219. And the 1219 beefs it up to like 1K samples. So this is, this is a little bit more expensive. This is $1 more than the 2485. Maybe I can get this over here because this is not so important. I don't really care about package either. Boop. And then series, I don't care about that. And they're all going to be active. So maybe eventually they can have a little hide it. Okay. So 24-bit, this one, you get 1K. And then you have a couple more of the LTC and then another of the ADS. And then if you keep scrolling down, we do get to the ADS 122CO4. And this one it's much more expensive. It's like $2 more than the LTC. This one does 4 inputs, also 2 differential. But it gives you 2,000 samples per second. So the question is, are we willing to put up with 1 input and 7.5 samples per second? Probably. It's not bad. And for temperature measurements, you don't have to go very fast. However, I was looking at this and I was like, well, I think people would want to use it for maybe other measurements. If I was going to make a breakout board, it might not be just for temperature. It might be for, maybe people would use it for stuff like strain gauges or other Wheatstone bridges where they want faster results. So in the end, I actually sort of decided to check out the ADS 1219 because I think the 1,000 samples per second also means you can do oversampling and then averaging, which might be kind of nice, whereas I feel like 7.5 is sluggish. But 1K, you can do that over I2C pretty happily. So this is my pick for a 24-bit I2C ADC. Not the cheapest one, but I think is going to give you a really good result. And lots of it in stock at DigiKey. So check this out. The other one's also probably very good if you don't need 1,000 samples per second.
All right. That's a research.